Um, thanks for coming. Let's talk a little bit about decisions today. Doesn't matter that much. Yeah. Thanks. Okay. We'll talk a little bit about decisions and conditional logic today. Before that, we will do a little bit of hand waving. I'm not a big fan of it, but I promise you this makes sense. Okay, actually it doesn't, but we'll still do it. So who of you had to ever explain to someone how your system works? Raise your hand. Yes. Who had to explain to someone, let's say the business, why the system produced a particular result? Yes. Who had to, that might be a bit more tricky, who had to prove or at least convince someone that the implementation was correct as it was requested? Okay, now even more specific thingy. Who of you had issues coming from the fact that engineers didn't talk to the business enough, didn't understand the business domain enough? Still a couple of hands. Okay, and the last one, the technical one, who knows what is hierarchical data? Okay, more than it should, but it's fine. So this should give you a little bit of context what the presentation will be about. And I want to talk about Decisions4s that solves some of those issues. So let's talk about what it is. And instead of explaining, I will show you. So a small kind of demo. I don't do live coding, but so we will model a business logic for a pull request approval process. All of you should more or less be familiar with the domain. We will have 4 rules guiding that process. So unprotected branch requires a single approval. Protected branch requires 2 approvals. Admin can merge anything, but this sends a notification because it's unusual. And otherwise, nothing can be merged. Okay, so that's the logic we want to model. And that's my implementation of it. You can argue that I consciously made it a little bit more complicated than it could be. I can't deny nor confirm that claim, but even if you manage to simplify, it won't be by much because we just have a lot of logic there. Okay, so let's see how we can use Decisions4s to improve on that. We will be defining decision tables. Decision table, in that case, has input and output, which is self-explanatory. It has rules and a hit policy. Let's take it one by one. Input and output, as you can imagine, we have those fields. So on input, number of approvals, which is an int, information if the target branch is protected, which is a Boolean, and information if user is an admin, which is also a Boolean. We have the output, which says, like, should we allow merging, Boolean, and should we notify about unusual action, also a Boolean. And we start defining the rules. We have 2 parts of a rule. We have the matching logic, so all the conditions that have to be met, and we have the output, so what the given rule provides. Okay, so in that case, we say that number of approvals has to be bigger than 1, target branch has to be not protected, and we don't care if the user is an admin or not. We say that we allow merging and that we don't notify about unusual action. The rule 2, 2 approvals, protected branch, we still allow merging. Third rule, user is an admin, we don't care about anything else, and we notify about unusual action. And the last rule, by default, we say allow merging false, notify unusual action false. And then we combine all the things together. specify the rules, the name, and the hit policy. Now you might wonder, what is a hit policy? So let's explain on that. So you have all those rules, all of them produce output. You need to define what should be done with the rules that were satisfied. And you have a couple policies here. You can say only a single rule should be triggered and give me error otherwise. Or give me just the first result, combine the results, or just count the triggered rules. OK, so we have the table. Now we want to evaluate our business logic. That's pretty simple. We just specify the input. So, for example, 2 approvals, protected branch, not an admin, allow merging true, notify unusual action false. OK? Simple as that. Now, you might be asked how we got to that result, and Decisions4s comes with helps with that. So we have this result.makeDiagnostic string, and it tells you that we evaluate that decision with that hit policy. That was the result. That was the input, and we didn't satisfy the first rule because we didn't satisfy that condition. We satisfied that rule and produced that result. The format might not be perfect. It's secondary concern. Like, you can build your own. All the data is there, and if you need another format, you can build it. OK, now that's fine, but that's probably not enough to justify the existence of the library. So another feature that Decisions4s comes with is visualization of your logic. So all the logic we have defined can be visualized in a semi-readable format, for example, in Markdown. But that's not very impressive. Another visualization, which is a bit more tricky to get the final result, but it's a DMN. And now it's a good moment to talk a little bit about DMN. Anyone heard about it before? Perfect. So DMN stands for Decision Modeling Notation, and that was the primary source of inspiration for Decisions4s. DMN is a standard from business modeling community. It was created in the 2015 or something, open standard. It comes with quite a lot of tooling. Like, I wouldn't say a lot, but a significant amount. And we are using some parts of that tooling here to render the DMN file. So that is this 2XML. DMN file is just an XML, and then render it using the pre-existing tooling. So yes. And that's pretty much it, what the library does. I will show you one more thing. So imagine you don't have the data that you need for your evaluation. You need to fetch it from external API, right? And you have 15 rules or 20 rules or something, and some piece of data is used only at the very end. So it won't be needed for the majority of cases. So you probably don't want to make that call. You don't want to fetch everything up front because you will be doing redundant calls, which might be expensive. And this is relatively complicated to implement. Like, the more inputs you have, the trickier it gets. So Decisions4s comes with a special evaluation mode for that, where you specify inputs as IOs, and they will be evaluated only when needed and only once. They will get memoized otherwise. So it's a nice utility just to, yeah. So I hope it's cool. So that's all of it. There is nothing more. That's Decisions4s. Now we will talk about how it works. So as you have seen, the baseline for the library is higher-kinded-data, which is just a fancy name for case class with a type parameter of a higher kind. And all the case class parameters are wrapped in that. You might wonder what is the difference between higher-kinded-data and tagless final. My answer is that HKD is actually useful. And let's see why that claim. So usually, if you go with tagless final in your application, you will have one type. So it makes a little bit, it makes some sense for libraries where you want to be as generic as possible, but when you use that, you typically use it with just one type. This does not apply to the HKD in my case because I use it with a lot of different types. There is really a stronger reason to go that way. And we'll see those examples here. So, for example, the rule conditions that we specify, the matching logic, this is just input filled with expressions of t to Boolean. Okay? You might wonder what is an expression, and that's a good question. Expression is a very tiny abstraction in Decisions4s, a trait that can produce a given value and that can render itself to a string. Okay? As simple as it can get to be able to visualize the logic. So now we have our input. We say that expression of producing a function from t to Boolean is just a unary test. And the rule condition is the input filled with unary tests. That's how it looks if you inlined it, just in case to make it a bit more tangible. So let's define some expressions. So we check if int is positive. We check if the string is empty, and we fill the input with those expressions. Okay, another use case. So the decision input is just input case class filled with values. Okay, so you might know the ID from cuts, shapeless, even tapir. So Decisions4s, wrong button, sorry. It has the same thing. It's called value. I thought it may be a little bit more explicit, but whatever works. So you fill that in, and that's it. Another thing, rule output. So the output is the rule output is an output case class filled with expressions of type t, because we want to produce those values, but we also want to visualize it later on. So example, we define a simple expression literal that renders through the toString, and we fill the output with literals in that case. So the same case class reused again. Now decision output. So on the previous slide we have seen rule output of particular rule that has to be renderable. Now decision output is already just values. So it's already evaluated, and we reuse the same case class. And there is a couple of more. So some of you may know the trick with const. So we say that type const of a ignores the type argument and just returns an a. So through that we basically fix all the fields to become a string, and we can store names of fields in a case class. We can store the indexes. We can store the information if the particular condition was evaluated, like the result of the evaluation. We can store the rendered version of the expressions of both input and output. Okay. Now you may ask, can't we just use maps, right? Like, do we actually need those case classes and all that higher-kinded crap? The answer is not really, because first, doing heterogeneous maps is relatively complicated. It can be done, but it's not really that nice to use. You can't ensure a key set in a map on the compile time, and you don't get the IDE support. So that's why the case classes are superior. You might also wonder what's the connection between higher-kinded data and GADTs, generalized algebraic data types. There is some connection, but not a very important one. GADT is basically an ADT with type parameter. So yes, you can see GADT as a higher-kinded GADT. Doesn't really matter. Okay, so hopefully at this point you know what is higher counted data, you know why it was useful. Now let's talk a little bit on how to work with that, how to operate on this kind of structures. So in Decisions4s, Decisions4s comes with its own type class, which is called HKD, and it defines 3 methods: pure, mapk, and map2. So pure takes a polymorphic function from unit to a of t and produces a data of a. Okay, so it just allows you to create an instance. And where it is used in the rule default. So the thing we used for defining the final fourth rule. We say that default rule is the one where the input is filled with catch-all, so the always satisfied expression. Then mapk is allows us to transform data of A to data of B using a function that for any type t can go from A of t to B of t. Okay, so let's make it a bit more tangible. This is used inside the library, for example, when we evaluate or render stuff. So we take the whole output, inside we have expressions, and we call the expression.evaluate or expression.render for each field. Now map2 allows us to merge. We have a data of A, data of B, and a function from A of t, B of t to C of t, and then we get a data of C. So we take two instances, merge them together, field by field, and produce a result. How is that useful? In the evaluate, where we take the input of values, we merge it with the expressions, evaluate, so the unary test, if you remember, those are expression of a function from t to Boolean. So we evaluate, this produces a function, we apply that function with the input and get the result. Okay? Now, good news is that if you want to play with that concept, you don't have to implement all those operations by hand or the type classes. There is a library called HKD4s. It was released, I think, soon after Decisions4s, so both are young, but you have something to play with. I couldn't use it, even if it was released before, because I do some more or less crazy stuff inside Decisions4s to make it work, but it should be good for a more general purpose. Okay, about crazy stuff. Nesting is hard. Okay, so imagine you want to put foo inside the bar, and first thing you need to decide, do you want to wrap foo or not? So both foo and bars are HKDs, right? And this is a big difference. And a big decision to make. Turns out that in Decisions4s I have to wrap for reasons, but there is nothing that tells you ultimately if you should do this or not. It depends very much on the use case. And once you wrap, everything becomes really, really more complicated. So the mapk now have two variants. First of all, both of them requires a functor because you nested, so you need to be able to map over the wrapper, and then you also need to go from one wrapper to another wrapper, and then you have two variants because the order of operations differ. So depending on what order you do that, you have to choose one of them. The map2 I will not show you because I was not able to implement it any way that would be presentable. So that's the actual mess under the hood. So the implementation I have works for the usage I have. So I control all the usage, I verify that it's good enough. But I have no clue how to implement it for the general purpose of wrapped types. Now, storing metadata. Like you have seen the const trick, right? Now this also gets more complicated because you don't only store the thing you want, like a string, but you also store the same thing for your field. So yeah. Okay, a bit different topic. here is the list of different libraries or use cases for HKDs, just in case you're interested. So there are at least 3 libraries that try to use that for SQL. I think the Scala SQL might have from Lee might be the most popular, like with the biggest adoption. There is something resembling HKD in Tapir. So any Tapir usages around here? Yeah, so you probably know there is request T and then URI is either present or not. So that's kind of the same pattern. And I have seen it also used for validations in some places, not in the public, but it's possible. Okay, so you know what is Decisions4s, how it works. Now let's talk a little bit about Scala 3, because while I think the library could be created in Scala 2, it would be very cumbersome to both write it and use it. So let's see what makes it better in Scala 3. So first thing is type level functions, type lambdas. So we had them in Scala 2 with that rather complicated encoding. So no one is using that. If someone needs it, they go with kind projector. But kind projector is additional complexity added. It's a compiler plugin, additional complexity for your project. So in Scala 3, we get this nicer syntax. Another thing is polymorphic functions. So the only caveat is that the syntax is almost the same. If you look at that and that, the only difference is the added sign. So it gets misleading sometimes. But basically that's a polymorphic function type. So a function that takes a type parameter and transforms f to g. We had that in Scala 2, but only for methods. Like there was no way to make it a value out of that method. Okay. So that's how you use it in Scala 3. So you just can write a literal and call to option. Yeah, I already told you how it's used more or less in Decisions4s. Render, evaluate, all of that are polymorphic functions. Another thing, context function. So you had a dedicated talk, I think, about that. That's basically an implicit parameter moved to the value. You may wonder how it is used, because I have not shown you anything that might require it. And that's true, because I did it kind of on purpose. There is this thing called evaluation context, and the only thing it does in Decisions4s, it gives you access to the whole input. That's and then when you define the rule, you don't actually specify the conditions and the outputs. You specify the context functions. That in my examples they get auto-lifted. And why it is that way? For example, for you to be able to do something like that. So the output of a rule is the input combined. Okay, so that's or you can do the same for condition. You might want to verify two pieces of input against each other. Okay, and I think the last Scala 3 feature, it's the type class derivation. So yes, I need a custom type class to be able to treat something as input and output of a decision. And it could be done in Scala 2, but it's just much nicer in Scala 3. A single keyword under the hood. That's what makes it happen. Under the hood, I delegate to shapeless 3, but it doesn't matter. Doesn't leak anywhere. Okay, so you know all the basics. Now a bit more context around the library and the questions you might have. So why I build this particular thing? So I work at Swissborg, which is a fintech. Okay, there I work in the payments team, where we are responsible for inflow and outflow of money from the platform. So a lot of transactions. All those transactions go through dozens of checks. The checks that are defined by our compliance team, so anti-money, anti-financial crime, AFC, and as you can imagine, this is a very important piece of logic, and it's very important for that logic to be valid, because otherwise we have legal problems. Yes, they are defined by the business, and that's how the use case was born. We on and on had questions about how this check is implemented, how it works, how it behaves in a particular scenario. So that's the problem we wanted to solve. And then we realized we had different use cases for that. So we also have KYC checks, know your customer. We also have the payment routing, so through what path your transaction goes. And so turns out the problem is pretty generic. It applies to any piece of business logic, more or less. By the way, we're hiring. So Valentin told you yesterday that there are not so many Scala jobs, but we still have some, if you're interested. Okay, now if you look at GitHub, at Decisions4s, you might see that it's not published under my name, it's not published under Swissborg, it's published under Business4s. So you might wonder, what is Business4s? How many of you have read the announcement? Anyone? Okay, a few people, so not that much. So the Business4s is an initiative of mine, for now, to try to refocus Scala community a bit. So for now, Scala is focused very much on the technical problems. JSON parsings, effect systems, performance, distributed computing, all those things, while very important, they make very little interest to the business. Okay? So now through that, I want to build a set of tools that strengthen the collaboration of developers and the business side of things. So we have Decisions4s. There is the Workflows4s, which is like a proof of concept project that I will talk about at Scala next year. There is a small Scala style guide that tells you how to write Scala focused on the domain. So yeah. And there is a Discord. If you have ideas, if you want to join, come and let's build more stuff with that mindset. Okay, another question. Can we let the business edit the rules, right? Because right now they come from code, but if business define them, why they cannot write it, right? Actually, they can, in the sense that DMN was designed exactly with that in mind. Like in DMN, the business or business analysts use a special editor to produce this XML file that you later evaluate. And the problem with that is that it doesn't work. I know because I tried a couple of times. And why it doesn't work? First of all, the business don't have the will to do that often. Like, they're focused on different things. They are not developers, they are not building the system. They want to focus on their job, not to make stuff happen, not to replace developers. But even if they have the will, they often don't have the mindset. So to build stuff, you need a specific engineering mindset. They often lack that. So whatever they produce, it's not perfect. Even if they have the will and the mindset, they don't have the tools. They don't have the tools to test that thing, to version control it, to deploy it. So all of that can be built, but it's a cost. So I say, let's keep responsibility for building the system on the developer side and just expose the effect to the business. Another question that you might ask, can we do more? Is there more potential in the library? And I think there is a little bit of that. So we can do, for example, JSON serialization. Some people thought, okay, maybe we can transmit over the wire, and yes, that's technically possible. Another idea I had is that we can execute through SQL, not Scala, because you might define the rules and then you might have data in the database already. Why to bring it to memory? Just evaluate it in the SQL. And that's possible. The question is, should we? The fact that we can build something doesn't mean we should. So yes, if there is enough appetite, there is a chance this will be built, but for now, I think of the Decisions4s as a complete product. So you may ask, is it production ready? I would say yes, kind of. So it's there, it's released, it's feature complete, it's well tested. It's almost running in production for Swissborg. I have a branch where I integrate it into our code base. It's just it's passing all the tests. It's not running in prod yet. I just need to polish it a little bit. But if you try to use it, you will notice that it's just 0.01. Okay, so that might put some doubts in your head, and that's justified. And that's because the library was brewing for a long time. I released it only after I was convinced it has everything it should have. It's a complete product, that it works for a big chunk of the checks that I mentioned at Swissborg. So that's why it's just one version there, but don't be discouraged by that. Another question. Can you use it from Scala too? Because part of caring about the business is understanding that not every company can just jump into Scala free one day, from one day to another. And the answer to this is yes, kind of. So the thing is, you can evaluate the decision tables from Scala too. I think you can even render them. You can't define them. So if you want to define the rules, you have to have a small Scala-free submodule in your SBT build, where you define all the decision tables, and then you just evaluate from your code base. And that's pretty much it I have for you. So you can find all the slides here. Please go there, because I spent way too much time over the last 2 days redoing that page. Yeah, I want to leave you with that sentence: talk to the business, because for too often I see problems coming from the fact that developers don't understand their domain, they don't understand the business, they don't know how their product is used, why it works the way it does, why it was built that way. So, and it's really hard to do anything if you don't understand that. And the only way to understand that is to get closer to the people that actually are the business side of your projects. Thank you. Any questions? Yes?
Thanks for the presentation, first of all. Yeah, I have a question. Is there a generic or general way to compose, to sum maybe rules together? And my question comes from the fact that I saw that you shown us the heat policy, and there was a heat policy named combine, right?
Mm-hmm.
But I'd argue that that's a way to combine rules evaluation, or maybe rules results.
Yes.
Rules application
Yes.
result. Is there a general way to combine the two different rules together to get a third?
I think you mean combining decision tables, right?
No, actually the rules, the things that are getting evaluated.
Mm-hmm.
Is there a generic way to combine them together, to combine two rules to get a third rule? Or is it just done at the evaluation level, once you evaluate the rules?
Once you evaluate the rules. Okay, like if you have a use case for that, I'm happy to discuss. I just didn't need that at any point. It might be possible to combine the rules. It's just that you define the rules as they make sense, like domain sense, and then then they got rendered. They show up in the diagnostics. So they are not really meant for an intermediate product. Like you define the final thing. You can reuse expressions, for example, or stuff like that. But
thank you.
Any other questions? 1, 2. free. Thank you.